Welcome to Retro Upgrade. This is the Christmas special. I bought myself a lot of tools and stuff. Let's review them and take a look at them. They had a few nice deals at AliExpress, so I bought a lot. Okay, so let's take a look at what I got and the pricing and stuff. I show the prices up on the screen when because I don't remember them all, but they weren't expensive at all. We'll leave this for later because we will be testing this one. Okay, so I got a normal wall wart tester thingy. This measures how much current you're using and how many kilowatts you waste and stuff. I had one before. I used it for testing electronics actually, because you can plug in a charger here, a laptop charger or anything. You can see if it's drawing excessive amount of current or nothing at all. So if it's charging a laptop and it's not charging really, it could be the charger, and you can check it with this. Pretty decent. I think it was like 7 or 8 euros, so not too bad. I'll put up the price here. Next we have these. So I got a little bit tricked with these. Probably you can't really see what this is right out of the box. These are replacement pads for PCBs. Let's see if I can zoom in. As you can see, they are extremely small, but these can be used for repairing iPhones and other stuff that has minuscule pads like this or traces. These actually have a round tip at the end. You use a solder mask to glue on. It looks good. These two were like 2 euros for 2 of them, so I'm not unhappy, but I was thinking these were the big kind, that these pads are, let's say, SMD size. This could be used for SMD repair, the biggest ones they have here. Okay, I'm already ordered up a few of the large ones. Okay, while I have it zoomed in, let's take a look at something else that's small. I ordered up one of these. This is ESP32 S3. So this is a dual core ESP module, and the S3 is the new 240 megahertz one. It has some AI built-in stuff, has the Wi-Fi antenna. I haven't tried this out yet. I have another ESP. I'll be soldering the headers that came with it. Looks decent. Looks decently made. Cost about, I think, 7 or 8. Not too bad. Has 2 USB-C ports. I think one is for charging and one is for data transfer. Couldn't tell you which one yet because I don't use the ESP a lot. You can see here ESP32 S3. Then it says room. So that's, and it's a original brief or something. I'll be using this for my AI converter for composite to RGB. Hopefully this is powerful enough. It has 8 megabytes of RAM, this model, the R8, 16 R8. It has 8 megabytes of PS RAM, so hopefully that's enough to keep a couple of frames in buffer, so I can save them down to a SD card or something, because I need a lot of data to train the AI. Okay, let's go to the next one. Also bought a few extra things, because I'll be using the ESP32 that's 3.3 volts tolerant. I know I will be using it with some additional electronics that actually take 5 volts. I needed a few different voltages on the rails, so I bought these. These are micro power supply or inverter switching mode power supplies. Let's open up one of them. Let's take one that doesn't have the label. So this is a 5 volt one. So this takes a DC voltage and outputs 5 volts. Okay, I actually can't get into it. I had to use one of the tools I actually bought to get into this. Okay, so let's look at this. These look really good and they're really tiny. So this is a 5-volt one. That's the coil, the diode, the regulator or chip that, yeah, it's a MOSFET pretty much. So I don't know actually how it controls the pulse width. Maybe this is a combined package. And it has voltage in, ground, voltage out. So this is actually pin compatible if you put it like this for a 7805. These don't handle a lot of current. I'll put up the specs on the screen. But for a quick and dirty way of maybe you have a 5-volt board and you need 3 volts for something, 3.3 for example for the ESP32, you can get these. I think these are 400 milliamp, which should be enough for most cases. Maybe you need 2 to feed these things, but in any case these are quite usable. I can't really see a difference between the boards, so it's maybe a programming thing, or maybe the capacitors are different and it goes after that, or these chips are different. I'll have to check in a later video. The chips underneath seem exactly the same, so the design is really similar for the 3 and 5, and they are not marked what I can see. And I think this is a boost or a buck, I'm not really sure. Let's look at the specs. Okay, let's put these away. Next I bought this. Let's zoom out a bit. This is a RGB cable for, this is a crappy quality cable, obviously. I want it for the ends. So this is for the PlayStation 1 and 2. This is RGB out, so I can actually use it with my GBSC. And I'll be releasing shortly a video on the quality out from the GBSC plus the PlayStation 1 and 2. The quality is decent, but I'm pretty sure they forgot the resistor network and or capacitors inside here. Let's take a look. Here we go, let's take a look. Actually, there is some filtering here. They have a resistor, 3 capacitors, so this is set for NTSC. Usually they are resistors here instead for PAL, but I can check that later and modify this cable as needed. Usually this works nowadays. TVs aren't that picky. So those are for filtering out high spikes and decoupling. Okay, so let's push everything back in. Try to get it nice and tight. But I'll be checking a few schematics online and actually rebuilding this cable, obviously, because I don't trust the solder joints and stuff. I bought way too many of these and always had to do something to them to make them work well enough. Also, cabling wasn't very well shielded, so could be crosstalk from the audio channels or the composite channel into the video channel, so I don't want that. The quality otherwise of the connectors and stuff is really nice, and this you can split this here, as you can see here. This is probably just glued on like the Super Nintendo ones. You can buy these loose as well as these. I actually bought a few, they're still on their way, so I can make my own Super Nintendo and Sega connectors. Okay, let's go to penultimate one. Okay, so this is a pair of snips. Mine are destroyed. These ones look really good. Were about 6 or 7 euros too. These are my daily drivers, but they are destroyed. You can see the blade is completely shot. They don't even cut what's it called, a desoldering braid anymore. We have some here with some solder on, and I have to cut 3 or 4 times to get through. These ones, on the other hand, are a lot more heavy duty. They're a lot larger as well, you can see. But they still fit in nicely because it has the angled tip, and they're super sharp. So yeah, so these actually are nice. That has the cable stripper teeth as well for different gauges. Just put it in and pull. Instead of having this for the lever, it actually has the big ring here, which actually looks nice, and probably can handle a little more stress. Okay, now for the star of the show. I've been actually dying to try this. So this is an alternative to a desoldering station, or a vacuum pump assisted desolderer. This is a vacuum pump, just like the ones you usually have with the button on the side. I can't really find mine. Oh yeah, here it is. So this, and these actually produce more vacuum than the vacuum pump at the beginning when it starts sucking. So you can actually clear out holes a lot better with these. Problem is, from the time you move the iron to placing it and letting go of the button, like this, it loses a lot of heat on the joint, especially on ground planes and stuff, and it's really hard to clear it out. To clean these off, you can open them up at the tip, just like this one, and you can clean them off. This one, there are a few variants of this. There is a fully electronic one that goes up and down by itself with a solenoid. It's really beefy, it's like this thick, but this one was really cheap. It was like 3 euros. So I'm hoping this will let me heat up and desolder at the same time. It says 36 watts. Could be that it's correct, or at least that it uses 36 watts. There are some instructions on the backside. Plug-in power. Yeah. Let the nozzle warm up for about 10 minutes. Yeah, that's pretty common on these cheap irons, but it doesn't matter really. I can wait 10 minutes to desolder a chip without destroying the legs. And there should be some cleaning or something. There's an explanation here on how you do this, so not too bad. Let's say this is good enough. Okay, let's take this off. It shows a PCB on the picture, so I'm hoping it's really good for PCB work. I have a candidate for desoldering. This is just an old mouse. It has one of these sensors in the middle, and the DPI sensor for the laser. Has a lot of legs. These are quite small, so the tip here is, I would say, medium size, so would take any of these, but what I can see, I should be able to get enough heat and clear out all the holes. But that seems to be fine actually. Not too bad. There are a lot of through-hole components on this board, that's why I wanted to try. I'm probably going to try with something easier first, like the LEDs or something. Looks decent enough. So you pull in the push in the plunger, hold it on the joint, and just press the button. You move it around to transfer heat, and then it didn't let go that fast. Okay, so let's see how the suction feels. Not too bad. It has a decent amount of suction. Only thing I don't like, you can't hold it close because you will burn your fingers off. So you have to hold it back here. So you have to get used to holding the iron back. Let's do a comparison. Not too different from my iron. Of course, there are irons that have the tip right about here. And of course, if this is not hot enough, you can always use hot air in combination with this to get off stubborn components on old boards. This will be useful if it works for desoldering RAM chips on C64s, Commodore 64s, or old Nintendo consoles and stuff, and CPUs, a lot of through-hole stuff. Even for clearing out solder holes like the very stubborn ZX Spectrum one. Okay, so let's heat this up and try this out. While we wait, we can talk about today's sponsor, PCBWAY. They are currently having a Christmas special with a lot of coupons with great deals. What are you waiting for? Go over to PCBWAY's shared projects page. It's really cool. They have a lot of themed stuff for Christmas. You can get some PCB stuff. They also have their gift shop. There are some really nice deals. I actually used one of coupons myself for a project coming very soon. Okay, now back to the video. This is hot now. It's smoking. It said 10 minutes, but it's not too bad. Okay, so let's see if this actually outputs what it says it does. I'm fortunate enough to have a thermal camera on the phone. Thank you, Richard. This doesn't have any thermal control. So let's see, hottest point is down here actually. 100 and something, 150. Okay, the tip is getting hot. I like that the handle actually doesn't let it touch when you're resting it, so I think that's a design. The tip is still not warm. 100 and something degrees. That shouldn't melt solder. I could get a false positive on this because it's a flare, so could be that the actual temperature is a lot higher, but because of the reflectivity you lose a lot of information. So let's try this out. Okay, first test. Plunger in. I'm going to hold it like I hold a solder sucker pretty much. Let's go for this LED light over here with a through hole. This is without flux, putting new solder or anything else. That is not bad. Actually, let's try next one. It's a lot hotter than 100 degrees. That should be clear actually. I'm quite impressed. Okay, so let's see. Yep, these are loose. Obviously, okay, let's get a pair of tweezers that don't cut through the legs. There we go. One of these. Let's bend this up. Okay, no, it's just coming out. So sometimes there are small burrs that are still in the hole, but this came out quite nicely. Oh, for salvaging parts, this seems to work really well, especially for a 3 or 4 year old device. A De-soldering Station costs, if you want a decent one with a pump and everything, cost about 100 something euros. So this is not bad at all. And the one that has a solenoid inside and pushes up and down is too chunky for my taste, but it still costs about 40 euros. So let's see if I can get something else off the other LED. Okay, so let's see where the legs go. there and there. And this is without flux, by the way. If I put on flux, it probably works better. So let's try the other leg with flux. I would suggest a fan or something because it smokes quite a lot. My homemade jizz flux. This is just paste flux in IPA to make it a little more liquid, but it clumped up on me and looks like something else. If you don't know what I'm talking about, you're too young still and you don't need to know. Okay, let's go. There we go. Let's put on some flux and see how this works. I'm pretty sure this is lead free, so this is actually harder to desolder. Okay, so let's see where the leg goes. Right there. That is not half bad. Okay. Yep. That's loose. I'm pretty sure I can get it out with my fingers. Yep. I am thoroughly impressed. This is really really useful. Okay, let's try something more challenging. These buttons right here, these break quite easily if you put in too much heat. So let's try that out. That's 4 connections. I wonder how long this will last. I only see 2 connections. Oh well. Let's give it the best chance possible of working. The reason the button is hard to get off is not because it's hard actually, it's because the plastic parts melt on them if you have too much heat. That's why you can't use braid to take them off, for example. Okay, so let's see if I can give a nice clean shot. You move it around like this, get it loose, and that is actually amazing. It's getting quite hot on the handle where the connector is, right here. But it's easy enough to move around. I would suggest to strap this with a rubber band or something behind, like this, so it doesn't melt it. And try not to touch the hot side. I do that enough for everyone. Okay, so let's see. That is really fast actually. Yep, that is probably off. Okay, so let's see. No, and it's not even hot. That is. I'm impressed. I wasn't expecting it to be that good, because this can actually replace a real desoldering station for me. Because I'm not rich, I don't make a lot of money doing YouTube. I'm finally getting some from PCBWAY. Thanks a lot. I'm really happy to be sponsored by them, because that makes it a lot easier to put in some time without feeling it I don't get anything back. Because I don't have a lot of time, I work way too much. Okay, so let's try this out. I'm going to remove the laser. I'm not going to be using this for anything in particular. I just had the board lying around. I thought it was a good test. I'm going to do a more in-depth test of this on thicker ground planes like a PlayStation 3 or 4 for the HDMI port, for example. See if it can handle to clean out the holes, but that should be cool if it can. So let's go. Okay, let's see if we can put this right about the middle. How fast can I desolder this? So I'll do this in real time, okay? And these pins are quite tiny. Not the smallest ones I've worked with, but still tiny enough to make it hard to desolder. This is real time, by the way. I don't want to speed this part up. I want to show you accurate depiction of this. These are a lot of pins, so it can be that I have to go another round on them. But it's going quite well, actually. Faster than expected. I think I did that one twice, but yeah. That wasn't too bad. That went really fast. Okay, let's see if I can get under the chip. Oh yeah, I can just push from here. Oh, it did a really good job. These chips normally require desoldering a little bit and trying again, so you don't bend the pins like I did right there. Let's see. Okay, so some of them are still stuck. This one is still soldered right there. So let's give you a close-up of this, removing that. Okay, let's see if we can get a close-up shot. Can you see that? Yeah, you can. Okay, so this one. That scared me a bit. Just hold it against the leg and wait and suck. Yeah, well, it seems about clean. See any other that needs to be cleaned out to take that out? Okay, let's try to remove that one. I don't want to bend it too badly, so I'm going to do this. I'm going to use the spatula and push all pins at the same time. Okay, so one of the holes is not cleared out completely. Oh no, they are. It's just that it's a lot of legs. Okay, let's check this. I don't know why the blue light is blue here. I melted the cable for the holes are nice and clean. Let's turn this around. You can see through all of them. That is not bad. And the chip survived. This would be like a RAM chip or something. It would be this hard to remove it. All the legs seem to be fine. No bends. Not more than I did on purpose there. And they're actually quite clean, so I can actually put them in a socket even. I didn't melt the plastic. This is a plastic enclosure underneath. Okay, no. Okay, so recommendations. Should you buy this? If you don't have a vacuum station, yes, buy this. This is so much cheaper, so much easier to clear out holes. You wouldn't imagine how much easier it is. And I done it without flux even. Even this thing with high thermal mass, this has rather thick shielding. I'm pretty sure I can remove that quite easily. It's all these pins over here. Let's try that out. But it's already shown itself to be more capable than I thought it would. I was buying it in hopes of it being decent enough to do maybe some small chips, but I have higher hopes now for actually doing some proper work with this thing. Okay, so let's see. The only thing that bothers me, it's getting quite hot right there. Okay, so let's see this one. Okay. You always have the option of using let's see, some fresh solder on the joints. These are actually bigger than the hole, so I have to hold it at the angle. These are metal tabs. It's actually doing quite quick work of this. It's so fast, it heats up a lot. Okay, that should do it, right? Let's see. Yeah. Okay, so let's move the soldering iron, or de-soldering iron. This should still be hot. Yep, it's still hot. Don't do what I do, do what I say. Do not touch warm components. Okay, let's see if I can take this off. This is what the scroll wheel is attached to. Okay, so that could be the bent tabs right here. Yep. Tab is free. This one as well. Okay. It's not hot anymore, so let's wiggle it out. That is amazing. That's actually amazing. This is a pretty big metal can, and it did it without any issues actually. I won't be using these parts. Maybe the LED lights and the button I can save in my stockpile. Well, I could remove the LED lights, and I am missing some resistors, but resistors are so cheap. Okay, let's bring out the thermal camera and zoom out a bit. It's hot right here, so where you wouldn't expect it. I am expecting it to get hot here, but not up here. We will be doing a few Christmas specials with a few project videos. So let's see if we can get an accurate reading of this. So the handle is about 100 degrees there. It's not really 100, but you can't hold it there. But right here it's 50, so that's okay. And actually you would hold it from there to there, so that's fine. So it's hot, has a hot spot right there as well. So could be a quick and easy fix to insulate this with some thick exhaust tape or something. It's showing 100 and something degrees somewhere. Over 150. Yeah, okay, so that's the max this thing can do. Okay, let's disconnect this and have some final words, and that's it for today. This was a quick and short video, just to show my new stuff. I also got these. These are for a future project, for a ZX Spectrum ROM card made with a ESP32. So these are pin compatible with the ESP30 with a ZX Spectrum, but it's missing the leaf pin. It has a separating pin right here, and it doesn't have any sides. So I'll have to modify these. I have to cut off a little bit of plastic on both sides, or use a saw from here to here just to give it a edge it can slide into. These look good, and these are going to get bent down and be soldered onto a PCB. So you bend them from both sides in on each other, and sandwich them to the PCB and then solder it on. This is so I can extend and connect it directly to the ZX Spectrum, and then have a PCB cartridge so next one can connect on top. Okay, and I'll be making, maybe 3D printing the small separator that is a locating pin, so it doesn't go from side to side, because some of these traces actually have voltages 12, 9, 5 and 3.3. I think there's a 3.3. I'm not really sure now. But I'm going to use the ESP32, so I'm going to be using my 3.3 voltage regulators I showed before. Okay, that's enough on an update for now. Hopefully this was somewhat useful for someone. Big winner here, this one. I'm really impressed. I will be using this quite a lot. And actually these were quite nice as well. I like holding them. They're really high quality for being €6, or they feel high quality compared to these. These aren't bad, but I know the edge breaks quite easily on these. They're a lot cheaper as well. So okay, yeah. Thank you for watching until the end. Hope you enjoyed this video. See you on the next one. Bye. I really hope I recorded that. Yeah. That was amazing. I like it. I like it a lot.